Hi there, folks. Today we're looking at ratios and proportions. And so to start off, a ratio is the comparison of two quantities by division. And really, that's a fancy way of saying it's a fraction, all right? So remember, fraction bars are division symbols. When we write a ratio, we compare the two things using division. The division symbol we happen to use is the fraction bar. So a ratio, is very simply put, is a fraction where we're comparing two things, all right? For example, it says the Washington Monument is 555 feet tall. A replica of the monument is 18 inches tall. What is the ratio of the replica to the full-size monument? And the order in which it was written is important. It says replica to the full-size monument, which means the replica divided by the full-size monument. And so again, we compare them with division, but I use the fraction bar as my division sign. So 18 inches over 555 feet. And then just like any other fraction, I want to reduce this thing. These are each divisible by 3. So that's going to be 6 over 185. And it's important to keep the units here because that was inches compared to feet. And the reason that's important because this is a special kind of ratio that we call a rate. All right, a rate is a special kind of ratio where the things being compared have different units. So this would be an example of a rate. It's 6 inches for every 185 feet. Okay, and so that's what we call a rate. If these were the same units, which we could write these as the same units, if you think about that for a second, there would be another way to express this thing. I could say, hey, you know what? 185 feet, that's 2,220 inches. I just punched that into the calculator real quickly. And now it's inches over inches, so I don't have to write the units anymore, all right? Because essentially the units cancel out there. But now, once again, I could reduce that fraction. Now, this one didn't ask me to do this, but if I were to get the same units here, the ratio would be 1 over 370. And when I have the same units, it was inches over inches, the inches kind of cancel out just like we would with any other division. So this would be one version of the ratio. This would be another version of the ratio. That first version is what we call a rate. So it's a special kind of ratio. So keep that in mind. And unless it asks you to do it in the same units, you can do it as a rate. It really depends on the question. Okay, this one didn't specify, so doing the 6 inches over 185 feet is fine and expressing it as a rate. Okay, but now the thing about rates is we want to be able to convert back and forth. Like the one I just did, 185 feet, most of us can probably grab a calculator and say, okay, there's 12 inches for each foot, so 185 times 12 is 2,220 inches. But when they get a little bit more complicated, we want to use this thing called factor label. Okay. And so doing unit conversion, aka factor label, and if you've done this in science class before, they have their way of doing it, and we kind of have our way. They're really the same thing, except for kind of how we write it. But the thing you need to understand is when you're doing factor label or unit conversion, we're essentially just multiplying a bunch of fractions, okay? And we're setting up fractions that when we multiply, we can cancel out the units that we don't want. All right, and work our way to the units that we do want. All right, so change units by multiplying fractions that will cause units to cancel by cross-reducing. Remember, anytime we're multiplying fractions, we can reduce one numerator with the other denominator. All right, we can cross-reduce. And we just keep doing that until we end up with the units that we want. For example, if I look at something like this guy, it says if there are 12 inches in a foot, and 1 inch is equivalent to 2.54 centimeters, convert 3 feet to centimeters. And so when you see these things that compare the two units, like 12 inches goes to 1 foot, what that's describing is a ratio because it's comparing the two things. And so we could compare this with division. We could say, hey, this is the ratio of 12 inches over 1 foot. Or you could call it the ratio of 1 foot over 12 inches. Whenever we have two units that are kind of equivalent, but different units, we can write it as a ratio comparing the two things with division, all right? And it really depends on the situation in terms of which of those ratios we want, if we want the inches over the feet or the feet over the inches. The second thing, it says the 1 inch is equivalent to 2.54 centimeters. Once again, think of it as a ratio. Or you could do it the other way, 2.54 centimeters over 1 inch. But I'm writing that as a ratio. More specifically, it's a rate because we're comparing two different units. And so here's what I do. I start off with the thing that they give me, which is 3 feet. And I can always write anything over 1, so I put 3 feet over 1. I want to multiply by a fraction, okay? And what happens is I want to get rid of feet. I don't want feet, I want centimeters. And so in order to cancel out feet, I need to set up a fraction that has feet in the denominator because I can reduce this numerator with this denominator. It causes the feet to cancel. And so I have to look around at the ratios I have and say, okay, which ratio has feet in the denominator? And as you start scanning around, you should notice that this is the only one with feet in the denominator. So that's the ratio I want here. 12 inches goes to 1 foot. And what happens when the feet cancel, hopefully you can see that the only unit I have left is inches. But I need to ask myself, is inches the units that I want? And the answer is no, I want centimeters, so I need to cancel out those inches. So I need another fraction. And to cancel out the inches, I need inches in the denominator so that I can cross-reduce. See, now I need to find a fraction, one of these ratios, that has inches in the denominator. Notice there's two of them. There's this one right here, has inches in the denominator. And then there's this one right here that has inches in the denominator. And so I have to make a choice here. And keep in mind, I want to get to centimeters. If I used this one up here with the 12 inches and the 1 foot, the inches would cancel and I'd be left with feet. Well, that's not what I want. Look at this one. Here the inches would cancel. I'd be left with centimeters. Okay, so use the one that gets us to the units that we want. Okay, and so this one I'm going to use the centimeters guy. So that's a 2.54 over 1. Now the inches cancels. I can see that I have centimeters. This is just a bunch of fractions being multiplied. So I have 3 times 12 times the 2.54. That's my numerator. So that's 91.44 centimeters. And then the denominator, it's 1 times 1 times 1, which is 1. And then I finish doing my division. Okay? And I think I wrote it down wrong. 91. I said it, but I didn't write it. I was going to say 9.44 doesn't make sense. 91, sorry. I missed my 1 when I wrote it down. Okay? And that's it. But again, we're causing the units we don't want to cancel and seeing what we're left with. And if it's the units we want, great. If not, I have to multiply by another ratio. Okay? If I look at something like this guy, I want to know how many seconds are in 1.5 days. And see, we already know a bunch of, there's no ratios given here, but we already know a bunch of these conversions. Like, I know that 1 day, let's do them in green like I did before. I'm going to make a list over here. I know that 1 day is the same as 24 hours. See, so that would be one of the ratios I could use. Or, of course, I could write it the other way. 24 hours goes to 1 day. I also know that 1 hour is the same as 60 minutes. See, that's another ratio I can use. And again, I could write that the other way as well. I could do 60 minutes goes to 1 hour. That was a terrible looking, okay. And then I also know that 1 minute is the same as 60 seconds. And see, all of these things, I can write them as ratios, and this is what I'm going to use. I could write it the other way. 60 seconds goes to 1 minute. And now from here, watch this. Ready? Let's start with our factor label here. So 1.5 days. And then I just ask myself, okay, is days what I want? No, I want seconds. So I need days down here so that they cancel out. And as I look around, there's only one ratio that I know of that has days in the denominator, and it's this guy right here. It's the converting to hours. So I'm going to go from 1 day to 24 hours. And hours is not what I want, so the days cancel. I'm left with hours. But I don't want hours, so I need to convert that. So I need those hours to cancel. So I need to stick hours in the denominator. And of course, I look around and say, hey, there's two things that have hours in the denominator. There's this guy up here, which will bring me back to days. And there's this guy right here that'll bring me to minutes. And see, I have to just think, which one brings me closer to seconds, days or minutes? And the answer should be obvious. It's minutes. So I'm going to convert to minutes. And so it was 1 hour, 60 minutes. Now those hours will cancel out. So now I'm left with minutes. Once again, is minutes the thing I want? The answer is no. So I have to multiply again. And I need to stick minutes in the denominator so that they cancel. But now I have to think, all right, which of these ratios have minutes in the denominator? There's two of them, all right? There's this guy right here, which brings me to hours. And there's this guy right here, which brings me to seconds. And since seconds is the thing I want, it should be obvious that I should use the one that's marked seconds. And so it was 1 minute and 60 seconds. But now what happens is the minutes cancel. I'm left with seconds, which is the thing I want. So I multiply all those numerators. 1.5 times 24 times 60 times 60. And when I multiply out all those denominators, let's see, it was 129,600. That was seconds. When I multiply out all those denominators, I get a 1. And now I do the division. And you won't always get a 1 in the denominator. It really depends on what you're converting, okay? So it won't always be a 1 down there. We just have to multiply straight across, multiply it out, see what happens. And there it is, okay? That is a terrible looking C. My computer's being a little laggy right now. There we go, okay? Let's talk about proportions. A proportion is basically an equation that has two ratios set equal to each other. In other words, if we remember, a ratio is just a fraction, so it's a fraction equals a fraction. If I have a fraction equals a fraction, it's a proportion, and I can solve proportions by cross-multiplying. You'll see that extremes and mean thing over there. You do not have to know that. I like to throw it out there because you'll see that in geometry, okay? In geometry, you might talk about extremes and means. This is just a different way of writing a ratio, okay? Writing a ratio A over B is the same as writing the ratio A colon B. Writing the ratio C over D is the same as writing this guy, C colon D. And so the means, multiplying the extremes and means, is really the same thing as cross-multiplying if you have fractions. It literally yields the same result. And so you don't really ever have to know the extremes and means thing, because most of you are probably just going to see this thing and go, you know what, let me write that as C over D instead. And most of you are going to see this thing and write that as A over B instead. And now you're going to be in this situation where you'll cross-multiply, okay? And so if you remember cross-multiplying, our good buddy cross-multiplying, we just take numerator times the denominator equals numerator times the denominator. So in this one, you see the things in blue, it's C times B is C times B, equals A times D, the things in red, A times D. And that's it. Numerator times the denominator equals other numerator times the other denominator, all right? For example, if I look at something like this guy, again, I just cross-multiply, and I like to kind of do it as a path. I say, okay, 5 times x gives me a 5x, and I write it down. So I kind of draw little lines, all right? And then I do, 6 times 4, so I draw the 6 to the 4, gives me a 24, and then I slap an equal sign in between. That's it. That's cross-multiplying. And now I have an equation to solve. I undo multiplying by 5 by dividing each side by 5. And I could just do this as a decimal. That's fine. So that's going to give me a 4.8. Okay? But again, you just cross-multiply and solve the equation that's left. If I look at something like this guy, again, cross-multiply. I like to draw a little path. Visually, I like that. So I go, y times 9. So that's a 9y. And then I go, this guy, y plus 4 times 3. And here's the thing. Don't go doing too much at once here. If I want to do 3 times a y plus 4, it's times that whole thing, all right? Be careful, write out this step. That's our distributive property, so you have to distribute that 3, okay? So I've got 9y equals 3y plus 12. And now from here, my y's are on different sides. I can't combine them when they're on different sides, so I need to get rid of one of those y's. I'm going to get rid of the 3y by subtracting 3y. Whatever I do to one side, I have to do to the other side. And remember, this is how we handle when we have variables on both sides. So that gives me a 6y equals 12. And now to undo multiplying by 6, I divide by 6. And so I find out that y equals 2. Okay? This guy, again, same thing. On this one, it's written in kind of that funky format. Let's rewrite it as a fraction. Let's rewrite it as 15 over m plus 1 equals, let's write this guy as 3 over m. And see, this is why you don't have to remember the extremes and means. I write it a fraction, and now I get to cross multiply. And here's the thing. Some of you maybe are feeling a little bold here, and you're going, okay, 3 times n plus 1, I don't need to write that down. I can go ahead and distribute and rewrite that as 3. If I could choose the right color first, of course. I clearly have blue selected. We all know Smart Notebook is messing with me. 3m plus 3. And that's my distributive property. But again, write that step out if you need to. There's nothing wrong with showing some extra steps, okay? And then we've got 15m going the other way. Oh, sorry, I didn't draw my little path. All right, got to get those m's on the same side. I got to get rid of one of them, so I'm going to subtract the 3m. So I end up with 3 equals 12m. That is a terrible looking 3. I can do better, I promise. I believe in me. And now I have to divide each side by 12. I have to get rid of that times 12 by dividing each side by 12. And that's just a fraction. You can leave that as a fraction. You can say m equals, it's 3 over 12, but you still got to reduce that. That's a 1/4, okay? Or if you write it as a 0.25, that would be fine also, okay? But again, cross multiply. Numerator times the other denominator, other numerator times the first denominator, okay? You set those things equal. That's the thing that students always forget when they cross multiply. They remember to multiply the stuff, but they don't know what to do with that. They try writing it as another fraction. No, when you cross multiply, numerator times the denominator equals the other numerator times the other denominator, okay? How about something like this guy? It says a fundraiser is selling milk chocolate and dark chocolate candy bars. The ratio of dark chocolate to milk chocolate candy bars is 3 to 5. If the plan is to sell 240 candy bars, that's total, how many of each are needed? And so this is a little bit tricky, all right? And so here's the ratio. The ratio that they give me is 3, that's dark chocolate, to 5 milk chocolate, okay? So that's the ratio that I have. But as I go to set up a proportion, the big thing with proportions, when you set them up, is you got to make sure each fraction is set up the same way. In other words, if I did 3 over 5 for my first fraction, that was dark chocolate over milk chocolate, my second fraction has to be dark chocolate over milk chocolate. So maybe I'll call the dark chocolate candy bars D and the milk chocolate candy bars M. And the problem is I can't solve this. There's too many variables, all right? The information they give me is the total. And so if I think about that for a second, that ratio doesn't work. I need to think about the total. And anytime we are given a ratio like this, we're given 2 other ratios that we kind of forget about, all right? In other words, if it's 3 to 5 for dark chocolate to milk chocolate, it's 3 to 8 when we do dark chocolate to total. Or we could say it's 5 to 8 when we do milk chocolate to total. And when you think about it, the ratio here, it's describing the different parts of the whole. See, if 3 parts dark chocolate and 5 parts milk chocolate, that's a total of 8 parts. Okay, when you break it down to that basic unit of 3 to 5, that's a total of 8. Which means we automatically have the ratio 3 to 8 when I compare the dark chocolate to the total. I automatically have the ratio 5 to 8 when I compare the milk chocolate to the total. And here's the benefit. Ready? If I use that second one, it's 3 over 8. That's dark chocolate over total. So I don't know how many dark chocolate candy bars, so I'll call it D, but I do know the total. It was written right here as 240 candy bars. And see, now I can cross multiply and solve this thing. Okay, D times 8 is an 8D. 3 times the 240 is a 720. And now I can divide each side by 8. So that gives me 90. Okay. Likewise, I could do the same thing here. Ready? Let me do the other version of this thing. So that's 8 over 5. That's milk chocolate over total. So that means the other side of this proportion has to be milk chocolate over total. See, it has to match. It has to follow the same formatting. I don't know how many milk chocolate candy bars, but I know that there's a total of 240. The problem gave me that. And now I can cross multiply. 5 times the 240 is 1,200. And now I can divide each side by that 8. And it looks like that gives me 150. And there's a really easy quick check here. If you look, I have 90 and 150 for my dark chocolate to milk chocolate. Well, that ratio is supposed to be 3 to 5. Let's set it up as a ratio. Ready? Dark chocolate is 90 over the milk chocolate, which is 150. That was dark chocolate to milk chocolate. Hey, that reduces to 3 over 5. And now I'm back to that original ratio. See, I can check it using the original ratio. I can also check it this way. If I've got 90 of these guys and I've got 150 of these guys, add them up. Is that 240 candy bars? It sure is. Okay? And so again, when you're given a ratio, there are other ratios that you can come up with based on that. Just like in the unit conversion questions, we could flip them and use the ratio upside down. Here, when they give us the parts, we can always do the ratio for the total as well. Okay? But make sure when you set up the proportion that each thing is set up the same way. If the first proportion is milk chocolate over dark chocolate, the next ratio better be milk chocolate over dark chocolate. If it's milk chocolate over total, the next one better be milk chocolate over total. It has to match. It has to be the same format for each fraction. Okay?